Hi, my name is Madisetty. I'm presenting the codes project work for managing ML projects. The ask here is for us to choose and define a problem statement uh, and evaluate if it's a real business problem and if ML is a solution for this. Then explain our business understanding of the problem statement, what the target users and what the solution will, how the solution would benefit. And then explain what is our solution approach and validation mechanism, followed by the ML design process. Then finally, potential risks that we can see in production if this solution were implemented. The opportunity or the problem that I have chosen here is using a machine learning model to evaluate students' written responses in assessments and provide a score based on the predefined scoring rubric and scale. Is there a problem? Yes. Currently, manual raters are high to assess and evaluate millions of students' written responses in assessments and provide the scores. It's a highly manual process, time consuming, a lot of cost involved because you need to hire a lot of raters during the assessment period, manage the logistics, ensure they have all the workplace solutions like access to the scoring system, etc., and coordinate the entire process tightly and ensure that the process is completed within a stipulated time because the final scores need to be published on a scheduled date and cannot be delayed. Can ML solve it? Yes. If you can identify and train appropriate ML model or choose an LLM model, existing LLM model, and feed in the existing data to create the appropriate prompts, ML can definitely be an appropriate solution here. Does someone care? Obviously, the assessment organizations who spent a lot of money, the cost and the effort that takes to run those operations would definitely benefit from these solutions. Uh, so yes, there is a potential for this solution. Business understanding of the problem business mechanism. We discussed the problem in a previous slide. You know, student responses getting evaluated manually, scored manually, and the process inducing high operational costs and schedule risk. The target users here are the school districts and the independent assessment organizations. And it's really important for them to have a solution that can bring in operational efficiency and also ensure the score reporting is done on time to the students so that the students can pursue their further options. How do we define success for this particular business problem? Uh, Assessment organizations can successfully use the ML model to evaluate, score student responses, and publish the final scores with no escalations or grading related complaints from the students and parents. That's how the success is defined. A potential outcome metric would be the cost benefits and the operational efficiency improvements achieved by the assessment organization. The output metrics can be, the volume of test responses that are scored per day accurately. Potential relevant factors for could be, the eligibility of the written responses and the acceptance of the scores that are generated by the AI model by the student parent community. Obviously, owing to the inherent factors like bias and absence of human cognizance while evaluating the solution, while evaluating the scores. Solution validation plan or the solution concept here. The concept is to basically create an ML model that can be trained on vaster rich volume of historical assessment data and scores. The model then can be used to assess students' responses from current assessment on a set of scoring rubrics and provide the final scores. So getting into a bit detail into the solution, an LLM-based model, either the organization choose to pick an existing LLM model or decide to create their own LLM model specific to the education domain. For example, that can efficiently understand, interpret, and assess natural language, evaluate semantic content in the alignment with the scoring rubrics and score scale. Uh, that would be an appropriate solution. Uh, of course, the LLM model can be trained on student written responses from the previously concluded assessments. Barely, if you're using an existing LLM model, just feed in the historical responses into it and give it a prompt where the prompt would clearly include the scoring rubrics and the score scale that is intended to use, and evaluate the output the model is generating. Based upon the response that we see, you can uh, modify the prompt until the model is able to exactly generate a response uh, in, 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 in alignment to what has been expected. A validation plan could be, use an iterative approach to validate the solution. The input student responses can be segregated based on student demographics, previous scores, or any other relevant factors that is specific to that particular assessment, and then prompt the model to score the responses. Compare the final scores in each iteration, observe the variation, and refine the prompt. Um, so after doing multiple iterative approaches, we can conclude that if this particular solution or an ML solution is an appropriate uh, solution for the stated problem. ML system design. So the following system design decisions will be considered in the proposing the LLM based solution, right? So first one is cloud versus edge. Definitely the ML solution can be a cloud based solution as the processor can happen in cloud and the results can be delivered to the application directly. Since the scoring process is not required to be real time and results need to be published on a scheduled date after the assessment, a cloud-based ML solution is best suited here as it provides high throughput and low latency. Offline versus online learning. The model can be trained offline. New data that is generated after each assessment is concluded can be refined and fed into the pipeline of the model to be trained in offline mode. Obviously, the results can be evaluated and model performance can be fine-tuned by adjusting the parameters, thereby ensuring the model is relevant. Batch versus online predictions. Once the assessment is concluded, the student responses can be grouped into homogeneous batches. So definitely a batch process is a appropriate uh, method here. So once the responses are grouped into homogeneous batches, like example by subject or the question type or by the scoring rubric, and then put into the model for scoring. We don't need a real online prediction here. Potential risk in production environment. So training versus serving skew. So while we train the model on historical assessments, or if you're using an existing LLM model, the prompts that we finalize are generated by inputting the historical assessment data. So the new or the current assessment data can be different owing to various factors like the changing curriculum, the method of teaching that can impact the way students provide their written responses, etc. So this can cause a variation in the scores generated by the model that can be inconsistent. Data concept and drift. If the solution is already using an LLM model for scoring the responses, there is a scope for potential data or concept drift as the model itself is continuously being trained and evolving. The model interpretation of certain semantics from a scoring rubric point can be different from what is intended from an assessment standpoint. So this can use unintended bias in scoring process, thereby questioning the scores that are generated by the model. So that concludes the presentation. Thank you all for your time.